Okay. Hello, everyone. This is the DRA biweekly sync post for 2026. Um, let me share the agenda document and we can get started here. I'm going to paste the agenda link here in the chat if everyone can add their names. And be mindful, this meeting is recorded, so please follow the CNCF Code of Conduct. With that, we can get started. So I have a short update here. I have a PR out which proposes taking the DRA GPUs with DRA and host devices with DRA features to beta. There is not a lot of uh, design changes in that web, largely because all of the design changes are uh, consolidated into a Kubernetes enhancement. And the plan is that we'll remove some of the uh, device status information that was needed to calculate the PCI address and MDEV address in Virt Launcher to Kubernetes using the downward API. And I've mentioned that enhancement here, 5606. So a lot of the uh, design details are in 5606, which is the Kubernetes enhancement. And most the Web 10 update, which is pull request 155, only consumes the information that is present here. So yeah, I just wanted to give everyone a heads up. I have not been able to receive a lot of feedback and reviews on 155, so I've asked for um, an exception and additional days on this. Hopefully, we'll be able to get reviews and make progress. So, uh, yeah, let's see. Anyone have questions on that? Okay. If not, we can move to the next topic. Igor.
Yeah, hi. So this is kind of a short update about Web 16, and it was about supporting multifunctional PCI devices in the device plugin framework of KubeVirt. So I have been working with the web author, and we came to a conclusion that this solution basically can be taken out of the KubeVirt code tree, and the only thing that maybe could be in tree, or I don't know, it can also be solved by using a sidecar hook, is that if the multifunctional PCI topology needs to be like preserved inside the guest as well, instead of being created as a separate like PCI device, it should be like configured in the libvirt XML as a logical function of the same PCI device. So I will continue work with the author because he wants to create a generic DRA driver that can possibly live in the KubeVirt organization. But I have some concern because the use case, I don't know how broad it is, because the use case is actually interesting. It's about having like a cluster of workstations with the PCI hardware, and for the Linux kernel device driver developers to use that cluster to run CI automation. So that's why basically in the web it wasn't clear why the author want to use host devices to pass a network device or a GPU device. So the purpose was to pass it in raw mode. So in the guest operate in the guest OS, in the guest VM, they will be able to develop and test the driver code against the the PCI device that was passed through with all the logical functions. So, as I said, I don't know how broad this use case is, but maybe we can introduce this kind of solution for kernel driver developers in the KubeVirt community. Maybe someone would benefit from it. Yeah, so
Yeah,
that's
I
basically.
have. So I think I agree with some of the points you raised, and I have additional inputs as well. So, um, yeah, I'm also not sure whether this should live in the KubeVirt org. Uh, Having proven out a POC and being helpful outside, and then making a case of why this is helpful to others in the KubeVirt community can
Yeah,
be a good way to, see if we can bring it in. But directly starting from the generic driver from in the KubeVirt org, it seems like there is a lot of maintenance curve to it, and
yeah.
the use cases are very restricted. So
Mm-hmm.
that's first point. I think I agree with you there. The second thing, underneath the hoods, whether this multifunction device can be reused or a single function in the multifunction device can be used across two separate VMIs or not is a very um, is hard to handle. I mean, hard in the sense that if you talk about it from the Kubernetes point of view, in the DRA space, that is represented as partitionable devices. So think of partitionable devices as a bag of resources in which you declare that you can use these collection of resources in different resource claims, right? So now, if you have such a concept of resource sharing, which underneath the hoods are the same hardware resources, then whether you can use this multifunction device across different uh, pods or VMIs is an interesting one because you can either represent it as a normal device or a partitionable device, and in doing that you can enable and disable sharing the same hardware across different VMIs, right? I did not get a inherent sense whether the generic driver could generically, address both these cases. So in one case, the trade-off is that you want the hardware to be exclusive for one VMI. In the other case, you want the hardware to be shareable across uh, different functions, right? Um, And because that is not clear, I'm not sure if the driver can generically solve this. So we will need specific drivers for the use cases, is my sense.
Mm-hmm. I got you. I was focused on only one case about, I called it compound resources, where you actually, it's not partitionable, it's an exclusive, and you must ask all the explicitly ask for all the logical function devices of the whole PCI device. And the complexity was that the user needs to know ahead of time how to properly configure the VM API in terms of the DRA host devices. So he had to ask for explicitly all the logical functions in the DRA host devices.
I see.
So
Yeah, but again, if you make this a generic driver, then somebody will come up with a use case of sharing this
uh,
into
yeah,
devices, and then you'll have to account for that in the generic KubeVirt driver, which is why I think starting this small use case specific driver outside and then
yeah,
consolidating the use cases and bringing it in would be a better approach, in my
yeah,
opinion.
makes sense. Yeah, makes sense.
Okay. Uh,
Thanks.
yeah, that's all I had on this topic. I see Sebastian and Or are also on the call. Um, did you guys have anything to share slash discuss on the networking side? Uh, if not, we can conclude the call.
Hi, just the two PRs, the web and the design that you started to look on, the download API of the CDI. If once someone have time to review it, we'll be glad. I see that I will need to rebase the web on your 155 web because they're changing the same file. And then I will add the links later to the slides, to the notes. And there is a little more issue. I need to find it. I will also, about the request name, that as a bug at the moment for host devices and GPU, not related to network devices. I will paste also the link there if we can discuss offline what we want to do about it, please.
Sure.
Thank you.
So I just wanted to share some thoughts on the downward API PR that you have. Let me find that and put it here so everyone can be on the same page. I think it's this one, right? I added some comments on this, but the biggest thing I wanted to share is that the downward API PR, this one, is currently in the review phase in the Kubernetes community. So I'm actively working with work group device management to get that to a place where it is stable enough. So just wanted to give you a heads up that there will be some changes expected in the design and in the way things are currently written.
Mhm.
Yeah.
One.
And just to finish, the
Mhm.
the workgroup device management call is at 11:30 in 15 minutes. So if we wrap this call up early, I will present this design there as well, and I'm planning to have a discussion and get some reviews in that call.
Yeah, I also from my side, I'm planning to join like that meeting.
Awesome.
So yeah, so just wanted to say one thing here, and I need to like do another round of review on your PR. That's great. That's a feature we for networking really need to try understand not only for KubeVirt in this case, but also for telco use cases when you can have like a dozen of virtual functions connected. You need to know which network is what and how to do the connection for their DPTK applications. So that's the use case for us. And on device plugins, so we have environment variables. That's how we do today. One thing that I need to see carefully there, I saw your comment like quickly just before this meeting, didn't have a time to go like full over it. One thing important is, if possible, we should try to avoid requesting the customers or users of the application do some pooling on files. So we need to try and be sure that when the pod start, the CDI configure, like the file that is exposed by CDI has all the needed information, because changing like customer applications to start doing pooling and things like that, it's going to be much more complicated if possible. So I just need to read carefully what you did there, so to see why there is a need for the pooling.
So I think that polling came from one of your comments, which said that when the DRA hook, the node prepare resources, is called, uh, some of the networking information is not available to the driver yet. It's actually available at the NRI plugin hook. So we needed a way to update this file, right?
Yeah.
So now you can imagine that if some information is available after the node prepare resources hook in NRI plugin, then I'm assuming there will be cases in the future where information will be available, just after, let's say, init container starts, or something in the pod sandbox happens. And to account for all those cases that could come up in the future, I just introduced a generic generation number in the API. So if anyone wants to, have any advanced cases where information is available, let's say few seconds after the pod starts, then they can also call this writable or metadata write function, which will automatically uh, gen- advance the generation number, and the application will able to understand that. But
Yeah.
if this is
Yeah.
not your use case, then we can probably go back and make
Mhm.
it stricter.
So me and Or did some tested on this one in the case where on the node resource. So what Or did is on the node resource prepare for DRA hook, we are uh, creating an empty CDI file and also doing the like passing the CDI mount configuration, and we put all the information on the NRI hook and we run a test like I think Or did like 100 times, and every time just this like the millisecond the pod start we did like a cut for the file, and every time the information was available, so we didn't catch that race condition that I was scared about. And like also checking the Kubernetes code itself, I think like on the pod sandbox create, so there is still no pod, so it's okay adding the information there, and it will be available just the second the pod start. One use case for what you did can be if in the future we support like hot plugs for containers, that will be great, but DRA right now doesn't support that. So I don't know if we should go that way or not until we have the hot plug.
Yeah, I so theoretically, so yeah, I want to be careful here. If the race is could be present theoretically, that is still concerning when we are designing this in Kubernetes, right? The fact that we are not able to catch it in our tests just means that somebody else will run at high enough scale that they'll be able to catch it and then
Yeah,
start reporting bugs on this.
yeah, yeah. I agree with you. We can go with the generation like in the to be on the safe side, and if someone really caught this one, then we can tell him, yeah, you need in your pod to implement a pooling to get the right information. I'm fine with that.
I
Yeah, and they can also do this in init container. They don't really have to change the application part for this, right?
Yeah, yeah, interesting. That's a good point. Yeah. So the init container will wait for it and then to populate the information, and then the real container will start. That's interesting
Yes.
one. Yeah.
it's maybe also fixing the NRI 2 seconds timeout problem you said, if we have init container.
No, no. So NRI hook timeout, that's something completely else. That's a networking problem, I would say. But yeah,
Okay.
that something else. Just to put here in information. So by default, at least in Cryo, I don't know in Containerd how much is the time, but on Cryo you have a 2 second timeout for plugins, for NRI plugins, meaning that if you're say, for example, the DRA SRV driver, if you want to add like 100 virtual functions and you need to do VLANing and driver changing, things like that, that will take a bit more than 2 seconds, but the pod will just start. Okay, so on NRI, there is no blocking. Like if so to not have a deadlock on the system, the way they develop that one is that if the NRI plugin doesn't answer on its right like on that time, it will just continue without waiting for the information. And it's funny, like you see the pod start and you start seeing like virtual functions be added one after the other after the pod is already running. So yeah, but
So
that's a
in that
completely
case,
different problem.
but in that case, you will need something like a generation number to make sure that the application reliably gets the information that the plugin is giving, right?
Yeah,
Or that
yeah.
is separate.
We are working like in a different front. We are working with the NRI, like the CDI, the container runtime folks to try and see if we can have a different mechanism like a keep alive or something like that to know the webhook is alive and working, and this way we will not have the 2 second issues here. Of course, we have for now a super easy solution that it's extending a bit the time, like for 5 seconds, and then that at least on my testing everything was working. But again, if you have super high scaling starting hundreds of pods requesting hundreds of virtual functions, that may be even past the 5 seconds. So yeah, but this one is like working in a different front with the container runtime interfaces fork.
Okay.
One thing, please, about the arrays that we spoke about before. Besides that we run it locally, empirically, we also looked on the CDI mounting before the NI run runs, if I understand correctly. And then the NRI, as part of the create sandbox, even before the containers are created, already writes the file. So once you do create container, you have the file for sure. Again, I'm talking about only SROV, and I'm just learning, so please keep me honest here. I'm not sure if it is on Kubernetes the same, but at least on the driver, it's not just that we run it locally. We also looked on the flow. The sandbox is created before, we write the file even before we return from the sandbox in the NRI hook.
So what will happen if the NRI hook pod is not available while the sandbox is being executed?
Again, please.
Yeah, so in that case, it will be like even worse. Like the service CNI will not run and the device will not be available. But they are running on the same pod. So this means you can have like a race condition when the first part, the NRI hook part, pass, let's say, and then the DRA daemon for some reason goes to reboot or something like that, and no one's calling NRI. So yeah, the pod will start without devices because you don't have the CNI part that doing his magic.
Yeah, exactly. And so for those corner cases, we will need something in the pod to make sure that it waits and catches all those issues.
Yeah.
I really think that the additional stuff that I have added in the design, the generation number and the driver name, I wanted to stay away from that complexity because it is just creating more things for the DRA driver implementers to learn and implement. But it seems like in order to get the reliability that we need, that is going to be necessary. So if we can find out all the theoretical cases where we need this and kind of eliminate them one by one, and if we don't end up needing it, then that's just even better. But if we do need it, then let's have it and make it robust enough
Yeah,
for
I
people
agree
to
with
use
you.
it.
Yeah.
Okay. Well, that's all I had on this topic. Anyone else have things to discuss? If not, we can jump to workgroup device management in 4 minutes.
Thank you.
Okay, awesome. Thanks, folks.
Thank
We'll
you.
catch you in a couple weeks.
Thank you.
Thanks.
Bye.